if you don't have double spans, it should be fine, right? So you have in Ethereum, you have things like uncle rewards. So those blocks that are side-loaded here are called uncles, and basically a block can have a parent and an uncle, and yeah, and if there are different transactions there, they can still be used or deemed good, and that allows them to make way faster block time without really, compromising the verification. Actually, well, it is, people want to wait a few more blocks in Ethereum than in Bitcoin. In Bitcoin, to be sort of sure, you're supposed to wait about 6 blocks. In Ethereum, a similar level of securities, I believe, I hope I don't get this wrong, at about 12 blocks, something like that. But block time in Ethereum is, I think, 15 seconds or so. So it's way faster. All right, so that's one way, but that doesn't solve the fundamental problem of all transactions meeting in one place, right? So what are the other approaches? One cool approach, or cool, well, some people think it's not that cool, is Bitcoin NG, implemented in waves. So what they basically do is they, a node which mines the next blocks becomes sort of, we call it, I sometimes call it the king of the network, and it signs all transactions for a while, splitting the reward with the node that will be the king for the next block, whoever that happens to be. So for a certain amount of, for one block time, you really have, you have this sort of centralization, but the central node is switched around all the time. So that, of course, is a little bit faster, but still, first of all, it seems a little less secure, and then, for various reasons, and then also, well, it doesn't scale infinitely. It's just a little bit faster, but again, the problem that all transactions have to meet at one place persists, right? So then there's Ripple. Ripple is not really a blockchain. Ripple is quite fast as well. I think they say they support up to 1,000 transactions a second or so. Anybody can verify that? Any Ripple fans here? Who's a fan of Ripple? Hands up. Actually, I'm not, but yeah. Okay, so no fans of Ripple. Anyway, so do you want to hear about Ripple? Or maybe we should skip that.
Oh,
skip it. Really? No? Anybody want to hear about Ripple? No. Okay. Next. Tangle. They have a cool drawing. That's straight from their white paper. So Tangle is this blockchain-like structure. Basically, what they say is, let's have each transaction 2 parents, and then if you want to mine, you actually don't mine it. You just tie your transaction to 2 other transactions, and they call it a tangle or a mesh, and it's supposed to be faster and secure. There are some problems with securities because you can always split this mesh and try a second transaction. Analysis of this thing is a nightmare, actually, and they say you don't mine it, but to prevent a Sybil attack, they basically have to assume that the honest nodes in the system, there are more honest nodes, or honest nodes do more transactions than the dishonest nodes, and they also have to put a cap on the size of the transaction, and then it sort of works. So there are some dilemmas as to whether it's really secure, but well, I'd be lying if I said it doesn't look cool, and it's a very interesting idea, I think. Alright, so that's IOTA Tangle. I think what they could...
I have a question.
Yes?
Do you know how can I check the global state of Tangle? So
yeah, well, basically you should monitor all transactions, and the idea they have is you don't have to have the whole state, is you just have to have, you know, you just have to catch 2 transactions from somewhere, right, within the mesh. And yeah, it's problematic to get a whole, you know, ledger sort of things, and yeah, maybe that's why it didn't really kick off that greatly. Well, if you have a list of transactions, then basically you can process it and make it to be a ledger, right? There might be problems if those head transactions are, you know, a double spend. So for example, this one and this one, if they're a double spend, well, you have a problem. But if from the transaction you wanna go, you can build a tree, right? So from your transaction you have 2 parents. Then those should have 2 parents. They might, you know, overlap, but basically you can go all the way to the first transaction again. And if in that fragment of the tangle everything's okay from your perspective, so you don't really need, you know, to know the state of a node that you don't transact with, then for you it's okay, right? And for the mesh not to split, they require that you they require that you fetch recent transactions to you know, to tie them to your transaction. Yeah, so they say it's faster. I think it's difficult to analyze, but yeah, that's Tangle for you. All right, so I'll be talking a little bit about our solution. A quick sketch. It's called Multichain, which is a little bit reflected in our logo here. So let's first go back and think about, you know, what we can do here. So basically, when we think how to make a blockchain secure, right? Well, first you can have everybody verify everything. That's a pretty solid security model, and that's sort of, you know, the current Bitcoin blockchain. But that, of course, can't scale, as we shown previously, right? So, my space is limited here. I'll be static. All right, so then you can trust selected nodes to verify. So an example of that would be Ripple, in a way, where they have, you know, sort of proof of authority or proof of identity. Or even if you think about Bitcoin NG and waves, you know, you sort of give this trust for a limited period to someone. You also have systems which are called delegated proof of stake, where people delegate their stake to someone and then selected nodes only mine. So basically you can concentrate the power, the voting power in a system back to some powerful nodes, and then those nodes, because they're powerful, you can crank the parameters up, right? And ta-da, you have a faster system. But then there are 2 problems. It's basically trust, and then again, the amount of nodes where you have to delegate the trust, it's smaller and smaller as the requirements for power of those nodes grows, right? So say you want to delegate your stake, or, you know, delegate the verifying of the transactions to someone who has a data center which is connected with, I don't know, 100 gigabits or, you know, more pipe to the internet, right? So then you can find only a few people who have such hardware, such, you know, possibilities. So there are some problems. And then there's the third approach, and we believe it's the right approach. Basically, be able to split the streams of transactions in such ways that you can verify selectively, and you can have many parts of a network be verified by many people, but not everything by everyone, right? So if you can incentivize people to not cheat, you should get a solid system and scalable. And by scalable, it's important maybe to make a distinction between fast and scalable, right? Because fast is, you know, an algorithm that runs twice as fast on this exact computer, right? So that's a fast algorithm. It's a faster algorithm than the other algorithm. But scalable is basically, we need it to be 10 times as fast. Okay, so give me 10 more machines or 9 more machines, and it scales, right? You need more, throw more machines at it, it scales. So the holy grail is probably a scalable blockchain, not really a fast blockchain. If we can get both, then great, right? All right, so here we have a DAG like in Ghost, and basically our system looks sort of like this. So basically you have many chains happening in parallel, and then people who have stakes on those chains put hashes of blocks which seem verified already onto something we call the master chain. So those subchains are those parts that we want many people to verify, but not everybody, right? So yeah, and an important thing to notice also is that not all transactions are born equal. So a thing to consider is that some transactions you can have localized subchains, and you can use even maybe geographical, you know, proximity to sort of optimize the system. All right. So I hear your concerns already. So what would be the concerns? Or maybe I should do it like this. You read it already? No. Okay, so any problems with, anybody have any questions to that approach as is now, maybe? Or I'll go over my own concerns or our concerns and how we're fixing all those emerging problems.
So, do something like Lisk?
Lisk?
Yes.
I know little about Lisk, I'm sorry, so I'm not going
So,
to.
like plasma chains?
Similar, yeah, Plasma is a similar idea. Exactly, and in a way sharding is a similar idea. So when we started working on this, there was no sharding, or sharding was not really popular. We didn't hear about it, and Plasma is also very recent. So I guess when you put good engineers on a similar problem, similar solutions will arise, right? So it's sort of funny how we think about things, we try to implement them, and then we read about other people on other parts of the world, and we're like, whoa, they have very similar ideas. So that's pretty cool, and yeah, well, good, we'll see.
The data leakage to the Ethereum team.
Maybe I don't think so, you know, I think they too have talented engineers, and yeah, probably, you know, probably they came up independently with their solution. I would like to hope, I hope that's the case. So, all right, so there are some concerns with that. So one thing that we're, you know, still working on is how to create or split off the subchains. So we start with one blockchain. When it's too slow, we split the chains off. So one question is how to split off who do you put in which subchain, right? Another question is how do you make the subchains secure? Basically, you want to have a big blockchain because the everybody's mining that one blockchain, right? And that makes all those 51% or 33% attacks harder, right? And then the other problem is, how do you transfer funds between addresses that are not in the same, that don't have funds in the same subchain, right? So those are the problems to solve basically in such an approach. Let's start with the splitting off. We have a few ways. So basically, one way is just randomly. So basically, we take a few bits of the address, or even if we split into, say, the most senior bit of the address and all the addresses that have 1 in front, you know, their funds are automatically transferred to subchain 1, and the others are transferred to subchain 0. Then, of course, we're investigating still clustering. So basically, when you look at the history of the blockchain, you can see that certain nodes transacted with some other nodes, right? And you can form a cluster within them. So expecting those nodes to further transact amongst themselves, right? You could optimize the system already. The problem is you have to have a deterministic clustering algorithm, and all the nodes have to agree when the split happens. And it's basically forced by the algorithm that which nodes get their funds to which subchain, right? And of course, you can imagine a system where it's done on demand. So a user can declare when a split is imminent, or the node of somebody can declare which subchain they prefer. And the group of people can say, hey, we want to be on the same subchain. So when a split happens, put us in the same subchain, right? So those are the options. Well, how you secure the subchains? That's an interesting one. So basically, we use proof of stake in something we call proof of collateral. I think now most people use proof of stake or develop proof of stake systems where the node can lose funds when they sort of cheat. So when they sign 2 conflicting transactions. But in the initial implementations, basically you signed with either naively, with either the amount of coins you have, or to prevent the richest node from staking again and again and again, you had something called coinage. So basically it was an integral of your coin over time, and it fell to 0 when you staked. So basically if you had, say, 10 coins, your coinage was 0, 10, 20, and so on, right? Until your coinage was the biggest, and then you had the biggest probability of staking a block. Well, what we thought is, why not invert the system? So if you have this stake already, you could use it basically as a collateral. So when somebody signs the block, and they are detected to sign 2 blocks, 2 alternative blocks, which have conflicting transactions, a double spend, you can basically take away from their funds, right? So we use proof of collateral, and then we lock this collateral, and when a block is confirmed a few times, somebody will try to put it on this master chain we've seen before. The master chain basically mostly contains only hashes of subchains. Who can put the hashes there? Basically people that have a stake in all the subchains that get their hashes put into the master chain. And everybody should observe the master, some subchains, probably the ones where they have funds, and also the master chain. So if somebody sees somebody is trying to put, bullshit into the master chain, they can call it, and the collateral is taken away. So basically, it's in a way Plasma similar. Somebody asked about Plasma. Oh, yeah, we have a Plasma fund. Great. All right, so it's in a way what they came in Plasma is very similar. So who read about Plasma? Who knows about Plasma? Hands up. All right, a few people. So Plasma is an approach where they split off subchains from the main chain. They still use a main chain which has full transactions and everything, and those subchains basically commit their state to the main chain, and if somebody sees something bad, they can sort of request the main chain to calculate the nodes that do the main chain to calculate the whole subchain history, sort of, right? And again, they have to use some collateral to incentivize people not to break the side chain. And this can happen hierarchically. So you can have the main chain, then split of subchains, then of those subchains you can again split subchains. So in a way it's very similar to our system. We just sort of think of because our system, Plasma, is a project that sort of looks in the Ethereum direction. Our project is a whole new blockchain, so we preferred to think of the main chain as a very simple construct with just mainly the hashes of the subchains, right? So that's the sort of difference between Plasma and our system, like a key difference. All right, so let's move on. Okay, I think I went over that, so I skipped. I already talked about that slide. Then there's the question of how to transfer funds between subchains. So one way is to basically teleport the coins from one chain to another chain and sign this by someone who is stake on both chains. And the other way is doing it similar to Lightning Network, or using actually a version of a Lightning Network. Anybody heard about the Lightning Network? All right, so almost everybody. So I have a few slides on Lightning Network. So yeah, let me talk about Lightning Network. Unless you guys know all about it, then I'll shut up. But okay, you want me to talk, I assume. Okay, so how does Lightning Network work? Lightning Network is a second layer approach. So you can have a blockchain, and then you can build a Lightning Network on top of that for most blockchains. So a few steps to setting up Lightning Network. The first thing that we have to sort of set up or consider is a secure one-to-one channel without actually putting things on the blockchain. How do we do that? Well, we imagine I want to trade with the colleague here who has a beard as well as me. So there's some mutual interest, I'd assume. And we want a fast channel between us, and we don't want to pay for putting the transactions onto the Bitcoin blockchain. It's very expensive right now, right? It's because it's slow also, because you have to pay a lot, so your transaction is the first in the queue. So transactions on the Bitcoin network are way too expensive to buy, say, water right now, right? So what we do is we both put, say, 10 Bitcoins into, or 10 coins, on whatever coin system, cryptocurrency system, into, in a way, a contract. So we have 10 coins. They're secure, and if say I want to buy water from him. What's your name? Good man. Nicodem, yeah. So I want to buy water from Nicodem actually I have the water. Say Nicodem wants to buy my water for 1 coin. So basically he signs a transaction and sends it to me, not onto the blockchain, that says we update the state of this common pool of money so that Paweł has 11 coins and I have 9 coins. Say I buy something from him, from 2 coins, right? So then, again, the state is updated, so instead of me having 11 coins and he 9 coins, then it's the other way around, right? 11 for him, 9 for me.
So this is a kind of deposit.
In a way, yes. It's a as long as our trade doesn't have a, you know, as long as the trade deficit either way doesn't reach 10 coins, we're fine, right? Because if I wanted to pay him, oh, I'm sorry. If I wanted to pay him 11 coins, that's not possible, right? Unless I have maybe, you know, already a low balance. So, okay, this works fine. What happens if I want to withdraw and get my coins onto the main network? Any of us, both of us can put a transaction onto the main blockchain that says, hey, we're taking our money back. So then the state, whatever it is, if it's say 1010, then 1010. If it's 119, we get our coins. What happens if one of us cheated? Then the other one has a certain time frame where he can put the transaction, because we have those one-to-one transactions, right? And they're all numbered and signed. So then, say Nicodem, if I were to cheat, Nicodem could prove that I cheated by sending a newer signed transactions by me that said I transferred to him more coins, right? If that's not the end of it, if that's not the end of history, then again I can send, hey, but there was one further transaction, right? So then the main chain can verify really if you know, if something bad happened. And if nobody raises any complaints, then, well, we're... So basically the idea is if I have a secure channel with Nicodem, and Nicodem has a secure channel to Beata. Where is Beata? She's gone. Oh yeah, over there. All right. So if I want to send money off-chain quickly to Beata, I basically send it to Nicodem and he sends it to Beata, right? That should work, except what if Nicodem cheats? So there's one more step. I give a special secret to Beata, and basically my transfer to Nicodem is conditional on him receiving a secret. And the secret I send to Beata straight ahead. So the whole chain of transfer is invalid on the main chain unless everybody has the secret, right? So this way we can basically do a lot of transactions off-chain. The only problem is, first we have to set up secure channels. Those secure channels are basically locked capital. And if there's a flow of money where there are, you know, trade deficits, so if money flows one way, then basically those channels will need to be re-established again and again and again. So those are the problems with Lightning Network, but otherwise it's a very cool idea, I think, and a very promising one. Alright, so this can also be used to send money between chains. In a way, you know, if you have somebody who has funds on both chains, right, you can transfer the money to them and they can transfer the money to somebody else on the other subchain. Alright, so this is basically it. Any questions, comments?
So it's Nebula only blockchain for transactions or also for smart contracts?
We haven't done smart contracts yet, but yes, of course, we plan smart contracts. Well, basically, if you look at a blockchain, it's a few layers, right? So the bottom layer sort of needs to send transactions which can be thought of data chunks, and then a verifying node also needs to know if this chunk of data is valid or not valid. So basically binary, accepted or not accepted. So once you have a system that reaches a consensus over time, then smart contracts are, you know, a smart contract is basically also a data chunk where you just say, was this say call to a method of a smart contract valid or not valid, right? So what we're concentrating on now is basically getting as fast a throughput of data of those transactions as possible, and we're building smart contracts into it later. But yeah, of course, I mean, you know, smart contracts are a technology that I think any blockchain, any modern blockchain should have. And even if you look at Bitcoin, you know, very simple smart contracts are possible on Bitcoin, but the language of the transactions is very simple. It doesn't have loops, and it has strong limits on the number of instructions. But then again, people are building things like RSK. So we'll see how it goes. I think RSK might get integrated with Litecoin. So yeah, we'll see.
Does the Krzysztof Domański works with you? I was sure that I was introduced to this squad.
Yeah, we parted ways with Krzysztof. He works on his own project right now.
Alright. What are your co-workers from? Is it from Poland as well? Or?
Most of our co-workers are from Poland, but we're now hiring a few people from United States and a few people from China. So we'll see how it goes. It's nothing official yet. You have to wait for announcements.
You're also trying to run an ICO, don't you?
Yes, of course. I mean, a crowdfunding campaign will probably be done, but we haven't announced anything regarding the ICO yet. So you'll have to stay tuned. Please subscribe to our newsletter and.
So what is the current state of progress?
The current state of progress? Well, we're writing the system. We're launching a pre-sale soon, so basically you can back us. Just drop an email or subscribe to our newsletter, and yeah. So and we're talking to various investors. So if you're interested in investing, please contact us. We're also hiring, so if you go to nebula.network/jobs, there are jobs there, so all talented people are welcome to join us.
My question was more about the technology stuff. So
The technology. Now we're concentrating on developing this multi-chain, making sure it's secure, working with our advisors to make sure it's, it works well, and that's our main focus right now, the multi-chain. We're also experimenting with sandboxes, with computation. In our platform, computation is done through basically calculation of small LLVM code chunks that are executed in a sandbox. We're also, thinking about storage, but our main focus right now is the multi-chain.
Okay, so thank you, Paweł.
Right. Thanks.
Przed nami krótka przerwa techniczna i zapraszamy za chwilę na następną prezentację.
Hello, good to be back. Good to see all of you. Today we'll talk about token economy and token design. Why about this subject? Because in last year we had like a lot of ICOs, so everyone was making token. And when you look closer on these projects, in many cases you can think, is there any sense in this token? So today we'll try to find the answer for this question. And if any of you have idea for a good blockchain project, you will also receive a framework how to design your own token. Is there anyone in the room who knows that guy? Please raise your hand. Not so many, because this is not crypto guy, this is Y guy. He's famous because of his TED talk a few years ago and the book called Starting with Why. He claims it doesn't matter what you do, it doesn't matter how you do it, the thing that matters is why you do this. So today we focus on why. Why do you need this token? So let's start with the quiz. Why the heck do you need a token? Answer A, everyone does. So I want to issue my own token as well. There is hype for that. It's cool to have a token, so I want to issue my own token. Answer B, to get rich. You know, ICOs, pump and dumps, market overvaluation. I just want to be rich. People are stupid, they will pay for my token. And answer C, to run the centralized system. What is correct answer? Answer A, please raise your hand. One person. Answer B, to get rich. More people. And finally, answer C, to run the centralized system. Few people. Yeah, you can combine. From my perspective, all answers are correct, they are valid. But today I will focus on the centralized systems. And when you look closer at the centralized system, we have a system that is decentralized. But what exactly does it mean? So system includes like two parts, the actors and the interactions between these actors and the system. So actor is anyone in the system who play any role, who can do anything. So, for example, in Bitcoin we have like three main actors, like miners, node operators, and users, and maybe 4 developers, but I will skip that group in my presentation. Interactions. It's everything that can be done in the system. It includes the good interactions, the thing we want people to do, and also bad interactions. This kind of things we want to avoid. So playing dirty, to cheat the system, and so on. And decentralization means there is no mama. So in this system, there is no one that is taking care of the system. No one who is saying what is good and what is bad, and no one that encourages good behavior and punish for the bad ones. For example, in our traditional internet, we have centralized entities like Facebook and Google, and if they decide that your account is not correct, they can just ban you. In this decentralized system, there is no way to do this, so we need to design our token to play the role of the mama, someone that takes care of the system, encourage people to play good, and punish if they play dirty. So let's look at the most famous example, Bitcoin Mama. So as I said, we have like 3 kind of actors: node operators, miners, and users. So let's take a look what we expect them to do. So we have node operators, and we need them to store the data of the blockchain, to hold all these copies of blockchain, and we also need them to validate blocks created by miners. And there are some things that we don't like if they will do this. So we don't want them to store like invalid data, to change something in the past, and we don't want them to make validation in correct way. So we don't want to, if the miner create correct valid block, we need nodes to say, yeah, the block is valid, and vice versa. The miners, we need them to run the network and secure the network. So they config transactions, put them in the blocks, and create these blocks and connect to the previous one by hashing mechanism to create the entire chain and secure the network. We want as many miners as possible to secure network, because if the mining power is high, then the possibility to make any fraud is lower. And of course, they also can play dirty. They can insert in the block invalid transactions like double spends, or they create invalid blocks. For example, maybe all transactions in the blocks are correct, but the reward for the miner, they say like, for now in Bitcoin, the reward is 12.5 Bitcoin. But some miner can say, it's not enough for me, I want 100. And we don't want them to do this. And finally, we have us and users, and we want them to just create transactions to use the network. They also can play dirty. They can try make invalid transactions like double spends, and they also can spam the network. So let's check if there's any incentive for node operators to play nice or any punishment to play dirty. Is anyone in this room who is running full node of Bitcoin? Please raise your hand. One person. Is any miner in this room? Please raise your hand. No one? Really? Yeah, so question to you, what is your name? Piotr. So, is there any reward for you that Bitcoin network paying you for running your node? No. So there is like no incentive for him to store the data, and the same to validate blocks. If the node operator will decide to play dirty, like change some data in the past, we just reject him from the network, because if he changed something in the past, then the hash of the next block is invalid, and the entire history after that is invalid. So we can easily reject him from the network. The same with the incorrect block validation. If I say this block is incorrect, but entire network is something different, then my opinion is just rejected. Miners. Is there any reward for miners to confirm transactions? Yes, there it is. It's called transaction fee. So any transaction in Bitcoin, we need to pay transaction fee, and miners include transactions in the block, and if they can choose, if there is more transactions than the space in the block, then just think about money and choose the transactions with higher fees. And they also create blocks, and there is also reward for that. So it's called Coinbase. At this time, 12.5 Bitcoins. So mining is the only way how the new Bitcoins are created, and always go to the miner, the person who mined the block. Is there any punishment for miners if they include invalid transactions in the block? Not directly, but if they do this, then the block is invalid itself, so it's not included in the blockchain. So to mine the block in Bitcoin is not easy. You need to invest a lot of money in hardware, in electricity, and wait some time when you will be lucky and able to mine the block. And when you have this opportunity, you want to use it to earn this 12.5 Bitcoins. But if you cheat and say, I want like 100, then you lost the opportunity and mining is not profitable at all. And finally, we have end users. Is there any incentive for us to use Bitcoin for transfer? Please raise your hand to think there is incentive for us to do this. No one, because there is not. There is punishment for that. We need to pay to use Bitcoin network. This transaction fee that is awarded for the miners. Is there any punishment for us if we send invalid transaction? No, it's not, because if you send invalid transaction, it's not included in the block, and you pay the fee only for transactions included in the block. But there is punishment for like spamming network because we have this transaction fee and the block size. So if there will be no transaction fee and no block size, me or you or any one of you can like do like millions of transactions in 1 second, and the miners won't be able to handle all of them. So the network will fail. Yes?
Yes, I have one problem with that. I think, you know, you're considering just one chain here, and actually, you know, if you spam the network with invalid transactions, those transactions don't get included, so transaction fees will not be deducted from you. You know, spam the network with whatever. So if you run or if you hold another cryptocurrency, for example, if you're on Bitcoin Cash and want somehow to prove that Bitcoin Cash is better than Bitcoin Core, you could spam the Bitcoin network just to, you know, show, hey, Bitcoin network sucks. So basically, there can be incentives to spam the network if you consider more systems or things outside.
Yeah, that is a very, very good point, that our system is not the only one. There are also other systems around, and the motivations from these systems also work for our system.
And one more note, you said there are no incentives for storing invalid data, which is generally true, but there is an interesting use case where you are someone who analyzes the blockchain and runs, say, a firm which uses AML on blockchain, so anti-money laundering. Or if you store this invalid data, you basically have a database of people who tried to cheat, which can be valuable.
Yeah, but in this case, I'm talking about the Bitcoin protocol at the low level.
Yes, but again, if somebody tried to cheat within the protocol, and you could, for example, obtain their IP addresses, that's some valuable data for, you know, for simply determining where the bad actors are.
Mm-hmm.
So there is some incentive for holding invalid data as well, just to police things.
Mm-hmm. Yeah, okay. You are right. The first thing you mentioned, that is very critical, because if you look at this table, so we don't care in the Bitcoin about node operators. We just give a word for miners and punish users also for the good behavior. So it looks at the first sight that it shouldn't work. But as Paweł mentioned, there's like other systems around us, and they also influence motivation of people. So for example, question for you, what's your motivation to run the full node of Bitcoin? Okay, so you just want to develop apps based on Bitcoin, so you need a full node. Yeah, so it's a perfect example. So I want to develop some software, and I have business based on Bitcoin network, so I need a full node to do this. And also, at the beginning, or maybe right now, people just like the idea of Bitcoin, to have decentralized, censorship-resistant network, and just like this idea, and run the nodes. And the same, we punish users for using our network, so they need to pay fee. But if you compare Bitcoin network with other solutions, in Bitcoin network there is value big enough for me to pay for these transactions. So for example, for high amount of money, it will be cheaper than other solutions. It can be faster if we talk about cross-border payments, and also is censorship resistant. So for some stuff, I cannot pay with PayPal or credit card, but I can pay with Bitcoin and pay transaction fee for that. So if you design your token, you need to understand the other systems and then can influence your users, and you don't have to care about all the stuff, because at the first sight you can think all these people, all these actors should have economic incentive to do their job, but they don't have. Yeah, so now let's imagine we want to design our decentralized mama, our token design. So the first thing, you need to list all your actors in this system, and then list all the interactions they can make each other and with the system. Firstly, the good ones, the ones that we want them to do. And this part is like quite easy, because if you have the idea, you know what you want from people. But there are also things that can play dirty, and this is like not so trivial, because people have tendency to find things that can be broken. So it's hard to predict all the ways how users can play dirty. And you need to think which actors need to be motivated to play nice in your systems, because maybe some other actors are motivated from outside, like in Bitcoin users and node operators. And how to motivate them. So the best motivation is like money, so economic incentive. The miners receive new Bitcoins, but you can also think in other directions. And how to punish bad ones. So prevention is better than punishment. So at the protocol level, you should design your system that to not allow people to break the rules. So the majority of your network that play nice can just reject any attempt of bad behavior. But in some cases, you need to make potential vector attack very expensive and hard to be made. And you need to think what is critical for your system. For example, in Bitcoin, the critical is to run a decentralized system which is secure. So we need to incentivize miners, but when you're going back to our spam protection problem, we don't want people to just spam easily network. So one guy just can spam and shut down entire network. So we need like spam prevention mechanism, the block size and transaction fee. But the same mechanism can be used by miners to increase the transaction fee. So they can on purpose spam the network to increase the fees and take bigger profit. But to do this, they need to cooperate each other. It's not easy. They need to invest some money, and they are not sure about the results. And even if they are succeed and the fees are going higher, the network is still running. So this is like not critical issue. Yeah, and there's like no perfect system. So your solution for one problem can lead to another problems. So we need to think about that and be sure that the critical issues are covered very good, and any small problems cannot destroy your network. To do this, you need like the wide view, because to design new economy, when you design your token, design new economy, you play with people's motivation, with people's life, and they can be very creative to play around your rules. So you need wide view. You need to check all your assumptions from all perspectives. So you cannot do this like in one weekend to just say with your colleagues and design the token model. It's too complicated. you need to do this like iterations. So the first idea, what do we need, how we can incentivize our actors, find any mistakes and go back. And we also need consultation, so you can use the knowledge of the people. Mostly cryptocurrencies and blockchain are open source. People are very open to share the knowledge. So you can go to meetup like this and talk to people about your idea, what they think about this. You can write a blog post and see what community think about your idea. And of course find advisors with big experience. And then finally, you should ask yourself if there is already something like that on the market. If there is any token that plays the role I need. If there is, you should just use it and you don't have to invite the will again. So right now we will talk a little bit about existing token models. And the first one, it was like very popular, the first popular token model. So token as a platform currency. So let's imagine you create a decentralized platform that provides any service, and to buy this service you need to pay with the token, and the seller receives this token. An example of this kind of token is Polish project Golem. You can buy computation power. To do this you need to pay Golem token. The other type of tokens are burnable tokens, and they are like solution for some problems with this one, because if all the platforms have his own token and are using like 10 or 20 different services, then I need for each of service different currency. So this is like, it's not good user experience. So I just want to pay with something that I have already in my wallet. If I need to exchange my money for different currency just with the service, it's complicated. So the decentralized platforms that use tokens as a currency, they're probably used by crypto freaks because for them they are very excited about the project, so they can exchange the token. But normal people, normal business don't care about this. They just want to pay easily. So this is like the problem for this moment. But in the future, we can solve this problem when we are able to exchange any token to any other token just almost in real time, almost for free. Then this problem will be solved, because I can have any token and on demand exchange this token for one. This is needed by the platform. But this causes another problem. If I can easily, almost at zero cost, exchange this token when I need this, then I don't need to hold this token. So no one will be holding this token, so the value of the token can go down. And burnable tokens are solution for that, or attempt to solve this issue. So the one type of burnable tokens is called proof of burn. So let's imagine that Golem use this model. In this case, again, I need the token to pay for the computing power, but I'm not sending these tokens to the provider. I just destroy them, and I make a sign that I destroy the tokens because I bought computation power from that guy. So, and some people are burning tokens to use the network. So the amount of tokens is going down. So the value of them should go up. And from time to time, the protocol can issue new tokens. They can decide how many of tokens should be created. But if I was reason to burn 10% of tokens, then I will also receive 10% of new tokens. So the people that provide value to platform receive the reward for that, and also the number of tokens is going down, so the price maybe will not go so much down. Another example is like in Binance exchange. So they accept fees if in any currency, in any trading per day trade, but they use some amount of this money to buy back these tokens and then destroy them. So there is like no new tokens, just amount of the tokens in the market is going down. So the assumption is that the price will also go up. Discount token, it's also example of the platform that I can say, I accept currencies, all the currencies, but if you pay with my token, the price for you will be lower. And also Binance is example of this kind of token. So as you see, we can, in one token, we can merge 2 or more different token models. Governance. So this is another mechanism. So I just need a token to decide how the centralized platform should work, how it should be updated, and so on. Already in the golden example, I mentioned that the organization can decide how many new tokens should be created. So who can decide about this? Of course, token holders. So this is the governance role of the tokens. And 2 examples of this kind of projects are 0x and to make a DAO. 0x is protocol for decentralized exchanges on Ethereum for ERC20 tokens. And technology stack of Ethereum is updating all the time, is going to be much better and better. So also the protocol of 0x needs to be improved, needs to be updated. And the holders of the token can decide what should be changed and when and how the updates should be executed. And MakerDAO is an organization responsible for issue a stablecoin. And this stablecoin can be created by anyone. If you just make a collateral based on Ethereum, you can create this token. And again, the MakerDAO token is used to governance this mechanism. So people are deciding how much of Ether you need to stake, you need to make a collateral to make the token. And also in the future, they will decide with which other asset can be used to make collaterals. Another example is token created registry. It means we want to have the registry or some good value information that someone would like to pay for this information, and from the other side, someone else would like to be inserted in this entry. An example of that is AdChain. Then have a registry of the domains that are playing fair with advertisement networks. So this data is important for advertisement networks. They would like to pay for that. And of course, the website owners would like to be on this list. And there is also a third group of people, curators, the holders of the token, and they handle all applications from the website. So I run the website and I want my website to be included in the list. So I'll make an application. To do this, I need to stake my tokens. If my application is correct, if there is value in my entry, then I'm included in the registry. If not, then I reject it and I'm losing my stake. Another example of tokens is called work token, and this token gives you a right to do some work from the network. So we have example like all the proof of stake mechanism. It's based on this assumption. So for example, if Ethereum will change to Casper to proof of stake, then to be able to mine new blocks, I need to stake my my tokens. So the tokens give me a right to do some job for the network, and of course from this job, if I do it good, I receive some reward. But if I play dirty, I can lose my stake. That's all from me. If you want to go deeper in this subject, there are links for interesting readings about token design. Any questions?
Can you show the slide before? Okay.
Yeah, thank you.